Hi friends, welcome to VK Lectures. This is the third lecture in our series where we are discussing the physics question paper of Karnataka SET 2020 and let us look into the 11th question. A simple question from probability. The three fair coins are tossed. Find the probability of getting one head and two tails. So write it in this form. So combination of three head over, so again combination of two heads, HHT, HTH, THH. So combination of two head is also over. Now combination of one head, HTT, THT, okay, then TTH over the combination of 0 head or 3T. So 1, 2, 3, 4, 5, 6, 7, 8. So 2 to the power 3, 8 combinations. Now we have to get one head and two tails. Wherever there is one head, you can take it. One head and two tails. From where you start writing the two tails? Here, one head, two tail. So here two tails. So 3 out of 8. So option C. Here you have a matrix given A equal to 1 by 3 into all 1 1 1. Now some properties, there is a property of the matrix. If all entries are same, then lambda equal to trace of this matrix, and all other lambdas are 0 0 etc up to n minus 1, where n is the order. So it will have n eigenvalues. Out of that n eigenvalue, one eigenvalue will be non-zero, that is trace. So here what is the trace? That is equal to 3. So trace equal to 3. Okay, so what are the eigenvalues? Lambda 1 equal to 3, lambda 2 equal to 0, lambda 3 equal to 0. Now but look at the matrix A. You have to divide it by 1 by 3. Now when you divide a matrix by 1 by 3, its eigenvalue will get reduced by 3. So lambda 1 is equal to 3 by 3, that is 1. Lambda 2 is 0 again. Lambda 3 equal to 0. Okay. Now what is the question? Find the value of determinant of e to the power a. Determinant means, determinant is nothing but product of eigenvalues. Product of eigenvalues. Now if lambda 1, lambda 2, lambda 3 are the eigenvalues of this matrix A, what are the eigenvalues of e to the power a? That is nothing but e to the power 1, e to the power 0 and e to the power 0. These are the eigenvalues of e to the power a. So what is the determinant? Determinant is product. E to the power 0 is 1, e to the power 0 is 1, e to the power 1 is e. So determinant equal to e. So your option B. Now here most of them will have a confusion. We are taking 1 by 3 from any one of the rows or columns. Is it applicable, or is this 1 by 3 only for this row? Any one of the row? No, this is for all matrix. Now when you are dealing with operations on matrix, operation means matrix operations like changing row, taking 1 by 3 out of a row, then it is given only from one row you will take out the common, but this 1 by 3 is common to all the matrices. Similarly, if you take the determinant of this matrix 1 1 1 1 1 1 1 1, then this determinant is nothing but 0, right? So this is also product of lambda 1, lambda 2 and lambda 3. Lambda 1 into lambda 2 is nothing but 0. Okay, then if you divide by 1 by 3, then the determinant this lambda also will reduce by 1 by 3. So lambda by 3 into lambda 1 by 3 into lambda 2 by 3 into lambda 3 by 3. So this is the determinant. If this one of them was not 0, you would get a value in this way. Okay. A particle thrown upward from Earth's surface reaches a height of 100 meters and returns back. The acceleration of the particle at its highest point of reach has a value. Now, this is the scenario. We have a particle, and this particle is moving at a above height and then coming down. Now the question is, at this point, what is the acceleration? This is 100 meters above. Okay. Now, at this point we know velocity equal to 0, because it reaches maximum height, its velocity will be equal to 0, and then it descends down. Then what about acceleration? The acceleration will remain same. It is 9.8 meter per second square. It will be g. Now suppose if you have any doubt, just look into this scenario. Suppose acceleration is equal to 0. Okay, if acceleration equal to 0, then let us take the force. Force is equal to mass into acceleration, that is equal to 0. That means force on this particle when it reaches this particular position is 0. If the force on this particle is 0, that means the particle is stationary, that is in equilibrium. Stationary, there is no external force, means it is stationary. If it is stationary, means it is standing in the mid-air. It doesn't happen, it is falling down. Now assume it is not equal to gravity, not equal to or acceleration not equal to gravity. In that case, what happens is, it will the time of flight, time taken to reach from this point to this point, for example if it is t, time taken by particle to reach from this point, let me tell A to B, if time taken is from A to B is equal to t, then time from B to A will be equal to t dash, if there is a change in acceleration. But we know time of flight is same. Time of flight means it's not a complete, like A to B will be equal to this, t dash must be equal to t. That is one part of the question. I mean, this is what it is. Now another idea, if on the surface at any point, if you go above, if you reach height above the ground, there is a difference in acceleration. The acceleration at this point is not equal to acceleration at this point. There is a change, but that change is very negligible. Depends on the height each. Now as you go down the earth, then also there is change in acceleration. What is that change? If you go up, the acceleration g dash is equal to g into 1 minus 2h divided by re, where re is the radius of earth, around 6.4 into 10 to the power 6 meter. Okay, now as you go down the earth, then also there is change in acceleration, that is given by 1 minus 2 not 2, there is h divided by re, there is no 2. So when you go down the earth also changes, when you go up the earth also changes. There is gravity. Even on International Space Station there is gravity. Even though we see people floating, here is still there is gravity due to earth. So this is what it is. Now in this question, if you put this height h equal to 100 meter, this is just 10 to the power 2, comparable to 10 to the this re, this value is very small, so our g dash will be almost equal to g. That is why in this question, but this question is an entirely different, this is not asking about what is the change, what will be the gravity at that point. Okay, so option is D. Friends, before going to our next question, let me just give you introduction to our Telegram channel. What are the things present in our Telegram channel? Okay, now our channel name is VK Lectures, and there we have got a few more problems and videos, and the problems can be solved using the polling system. And what is that polling system? Now here on the right hand side, what you're seeing is our 14th question, and below that you have got the polls. Okay, now you can also see how many number of people have answered this question, and here 4 members have answered. Out of this 4 members, 50% of them has given the correct answer, which is indicated by the color green. Okay, and if the answer is wrong, it will be given in red color. Okay, apart from the questions, our VK Lectures has also got a classroom where you can clear your doubts. Also you can put up new questions and also meet the experts. Okay, now let's go to the 14th question. Suppose the radius of the earth were shrink by 1%, its mass in the mass is remaining same, and acceleration due to gravity would be. Now what is the formula? G is equal to capital G by into m divided by r square. Now if there is a change in delta G, the G is constant, and change in delta m into r square, that means 2 times change in r, which means what? If there is 1% change in mass, there would be a equivalent 1% change in gravity, and if there is 1% change in radius, there will be an equivalent 2% change in gravity. Here radius should be same, here mass. Suppose in both, for mass there is 1% change, as well as for this radius there is 1%, their equivalent change will be 3%. Now if this formulas or this idea doesn't stick to your mind, you can go for usual method, that is assume our values are some constants, gm by r square. Now for this time being, we will take capital G, m and r are 1. Okay, so if G, m and r equal to 1, then our gravity is nothing but 1, acceleration due to gravity is equal to 1. Okay, now if there is a 1% change in 1% change in r, so our G is equal to this 1 and 1 would remain same. Instead of r square, we have 0.99. Instead of 1 we have 0.99. There is 1% change. So this is nothing but 1 divided by 0.9801. 99 square is 9801. This value is nearly equal to 1.0203. Okay. Now earlier you have 1, now you have 1.0203. What is the change? 0.0203. This is the change with respect to 1. So what is the percentage change? Just multiply by 100. So it will be 2.03%. So it is increasing by 2%. Now how to say whether it is increasing? Because it is inversely proportional. Inversely proportional. If the differential cross section in a scattering is equal to a square, where a is a constant, then total cross section. So what is given here? Here d sigma by d omega is equal to a square is given. This is the differential scattering cross section. Now what is asked? You are asked to find out sigma, the total cross section. So what you have to do, sigma is equal to integral a square d omega. That's equal to integral from where to where? 0 to pi. So integral 0 to pi a square d omega is nothing but 2 pi sine theta d theta. So 2 pi a square will come out because this is a constant. So 2 pi a square into integral sine theta d theta 0 to pi. This value is nothing but 2. Now we'll see that 2 pi a square into sine theta minus cos theta. From where to where? 0 to pi. Cos theta, from since it is minus, we will go with lower limit. So 2 pi a square into cos theta 1 minus cos pi minus 1. That's equal to 4 pi a square. So your option D. So you have to remember this formula, differential cross section formula, and as well as total cross section formula.